Here we go with Mr. Syrup, section 11G. Let's hit it.
Get that part out.
Keep it in there.
Do you even bother editing that?
So if I yell at a kid, if I tear into a kid or something, I keep it on there. It just becomes evidence.
Now he photoshops himself to look like a Sigma model.
Okay.
Why is Mr. Syrup teaching without a shirt on?
All right, I'm just kidding. I'm sorry, guys. My sense of humor is bad. You all knew that already. All right, can you press that back? Press that back. Pass those back. And don't pass those back. Yep. All right, homework out from last time. We did the odds, yes?
Yeah.
Yep. Oh.
Yay.
Wait, last night we did the odds?
So we only needed to do odds?
Thanks for paying attention. And let's see. So we got Cooper that still needs to make up a quiz. Landon.
I get it.
Kyle. Grant. Cooper again. Cooper again.
Whoa.
Grant. Olivia. Hannah.
I gotta finish that list.
Logan. Okay, I got your message. Peyton, you have another quiz you have to make up with me. Olivia, you have another quiz.
Peyton. Come on.
I know.
You're that coordinated.
No, I'm not. That's too easy.
So what was it we did last night? A, B, C, D, E, F? F?
Yeah.
The one with all the graphs.
One with all the graphs, and then the last page doesn't have it. All right. So questions on 1, 3, or 5. They're all going to be done very similar. Any questions on those? Sam can't ask because he's the only one who asks. 1, 3, or 5. Any of those? 3. You got it. 3's in the house. Come on. There we go. Number 3. We have f of x is equal to 2 over x minus 3. And then minus 1. So it asks for the domain. So the domain of this is going to go negative infinity to 3, 3 to infinity. Is that okay so far?
Yeah.
That just means we don't include 3.
Wouldn't it be HUD over there? Like the...
Square bracket means you include it.
Oh.
So you won't want to include it.
Okay, yeah.
And then roots. Let's see if we can figure out some roots if they exist. Roots will indeed exist on this because it does look like the whole graph does shift. It shifts both right, left, and up and down. And then let's look at the y-intercept. So let's get to these. We'll get to these in a sec. Okay, inserts. Nope, that's not what I want. Math, graph, Cartesian, down. Okay, so what is my vertical asymptote?
0. Wait, no.
0.
Negative.
-1.
It's not.
It's positive 3, isn't it?
Wait.
Where the denominator is 0.
Yeah, it's supposed
Is that all right so far? Where is my horizontal asymptote?
-1.
-1, good. So let's create our asymptotes first. Okay? I don't have a negative up here, so it's going to kind of be up on top. So my graph's going to look similar to this, and then this. Okay? Now we can kind of put in where our roots would take place. Because this crosses somewhere in here, we have a single root that's going to take place. That root means my y value is 0. Is that okay so far? Shh. Add 1 to both sides? Yeah, some kids out of control back there. Multiply each side by x minus 3, distribute over the 1, so x minus 3 equals 2, so x is equal to 5. So I have a root at 5 comma 0. So right there. Is that okay? It does indeed cross the y-intercept somewhere in here. So for the y-intercept, I'm going to plug 0 in for x into my original equation. So I'm going to get 2 over 0 minus 3 minus 1. And then doing the math there, so I get 2 over negative 3 minus 1. So I get negative 1 2/3. So right there,
Yeah.
roughly. Cool?
Yeah. Can we do number
I think, is that problem done?
Yeah.
Okay. Can you do what?
5?
5? Done the exact same way. It just doesn't shift down at all. So it sits at the y-axis.
Okay.
Okay?
What about number 6? Would you just
Okay, we did the odds, but thanks for paying attention. Number 6 said what? We'll get to those a little bit today. All right. Would you like to see 7, 9, or 11?
11.
Why 11?
I don't know. It's just a good number.
11 sound good?
Uh-huh.
All right, 11, here we go. Good shot. Sorry, slipped. 2 over x plus 4. Minus 3. All right, math, graph, Cartesian. All right, let's figure out our asymptotes. What's my vertical asymptote?
Posit the next.
Say it.
Negative 4.
Negative 4. Okay. What is my horizontal asymptote?
Negative 3.
Good. Everyone good with that? All right. This up here is not negative, so it's going to look something kind of like this. Something like this. That all right? All right. Domain. It's going to go from negative infinity to negative 4, and from negative 4 to infinity. Rounded brackets because we don't include the 4. What else is it asking for? Vertical asymptote. So my vertical asymptote is equal to x equals negative 4. So that's a vertical line. And the horizontal asymptote, my half, is equal to
Negative 3.
y equals negative 3. Cool. And then x-intercept. So it does appear that we should have an x-intercept because we have something in there. Okay. I just freehanded my graph, so I don't know if that's the exact point. So somewhere in there. X-intercept means I'm plugging 0 in for my y value. So I'm going to get 0 equals 2 over x plus 4 minus 3. Add 3. Yeah, so then I get 3x plus 12 equals 2. So 3x equals negative 10. X equals negative 10/3. So that's negative 3 1/3. 1, 2, 3. So right there. Yeah, that works. And then our other one is a what? Find the where it crosses the y-axis. So where it crosses the y-axis, I'm going to plug 0 in for my x and solve it. So if I plug 0 in, that becomes 2 over 4 minus 3. So that's 1/2 minus 3. So that's negative 2 1/2. There it is, 2 1/2.
That's right. Because you're teaching one heck of a communicator. Come on.
No, it's because you guys are bright. All right, and then let's look at the last page. 13, 15, 17, 19.
What's another page?
Yeah, thanks for paying attention. Any of those you'd like to look at?
Wait, what?
I got to figure out what 13, 15, and 17 means, so let's not ask about that. I really don't know what they're asking for.
Are they asking us to make it equal?
Rewrite the function so that y equals a single rational expression.
Are they?
I really don't know what they're asking. Huh? I know, it's like write a fraction and you have 1/2 sitting there. You take 1/2. Right. So I'm not sure what they're asking. So 19, I think is everyone okay with the vertical and horizontal asymptotes on these? All right, so I would say don't worry about turning in that third page, but if you turn in 1 through 12, that first page, go ahead and pass that forward. Make sure your names are on it.
Hell yeah.
Prevent the kid from just copying down and get passed up on the Blake's out of control on it.
That's all Blake does.
Because, you know, Drew's got all the answers. Drew has every answer ever. You pick up the answers from the hat. You choose on how with that.
Ichiro Suzuki.
Are you guys ready for the weekend?
Sam, no.
Ichiro.
Let's shave Sam's eyebrows off. You guys with me on this?
Yeah.
At least it'd give us cheap entertainment for the rest of the
Let's
week.
bully Sam.
My dude, I already got my
No,
head
it's cheap
shaved last
entertainment.
year. My dude.
Sam
Come on, my
dissecting a
dude.
pig with me.
Yeah, we're dissecting a pig in science.
Oh, I remember that.
So weird.
Sam's literally gonna go, that's freaking bro.
Now here's the question: did you have to? You had a live pig originally, and you had to smack him over the back of the head with a hammer?
You did not.
Maybe
That's
take
so
the-
bad that you are. That's so mean. Why would you ever do that to me?
Dude, this game is so fake.
No.
Like, actually.
Nah.
No.
No, that's what they do in
Hang him by the feet with the throat.
Yeah, they have people who hit them with big hammers.
No, that is.
That's a helmet. That's a helmet.
Now I'm thinking on your row.
That's what they used to do. Usually it's legal.
God, let's go.
What?
They used to do that. Whack it out.
So gross.
I'm just kidding.
You're disgusting.
All right,
Over.
Come on, big rice.
Over here.
Maybe the cow was just a cow. I'm kidding.
No,
It was a bad pun.
Then let's beat you there.
But I mean, let's be real here. All that fun.
Dude, Bryce Harper sucks.
That was making.
Alright.
I will tell you, if you want to know what the most wild thing that we were able to do, is I was down at the Wilkins Ranch, down in Springerville, Arizona. Gosh, this is 1987. And they said, all right, we are branding, dehorning, and castrating the calves.
Oh. I've done that before.
And I tell you what,
Makes a man out of you.
you don't want to get kicked by it, so you're holding it, and you have to hold the thing with something else while you...
Oh.
Yeah.
I'll just say it's this.
Honestly, I feel kind of bad for the cow.
It's annoying. They do it scream, you know? Like, why?
And then the dehorning is funny.
I would on the head.
Yeah, I'll tell you what, the cattle, and then you brand them, like, kind of wandering around and feel like, hey, what's going on now? That's a different...
That's bad, Blake. Why would you do that? That's so mean.
Hey! All right.
What you eat.
I didn't mean to forget you.
No,
All
it's fine.
right, so this is a little bit more into graphing rational functions. So as we talked about yesterday, you had the denominator that creates the vertical or the horizontal, the vertical asymptote, and if you're adding or subtracting, slow dance like 8th grade grant. Remember this? All right.
That's weird.
So now we're gonna have. We're not going to add or subtract something outside. We have a function over a function, which is fine. And if you have a function over a function, things can reduce sometimes. But as of today, this is from Form 1. If you had a over x minus h, so if you had 3 over x plus 2, you create the vertical asymptote because of where the denominator is equal to 0. The k value becomes the horizontal asymptote. Okay, this is all we worked on yesterday, and that's where the domain and range come in. Okay, and we can go ahead and graph this. We can say, hey, we have a vertical asymptote at -5. So that's what this one includes. And then I can have this at 3. Because we get this, and then we look here and say, okay, this is what our graph looks like for the most part. Okay, and then we can say we have a vertical asymptote at x equals -5 and a horizontal asymptote at y equals 3. Do we have roots? Again, this is what we just worked on. If we're looking for roots, this does exist because the asymptotes have shifted. You don't always have roots if you don't have a horizontal asymptote that moves up or below the thing. So if I have a root, I'm going to plug 0 in for my y value, plug it in. So I get 0 equals 7x plus 5 plus 3, subtract 3. 7 over x plus 5. 3x minus 15 equals 7. Negative 3x equals 22. So x equals negative 22 over 3. So that's negative 7 1/3. So 1, 2, 3, 4, 6, 7 1/3, like right there. And then you can find out, do we have or y-intercepts? And again, the y-intercept is when I'm going to plug 0 in for the x value. If I plug 0 in, I get 7 over 5 plus 3. So that's 1 2/5 plus 3. So that is 4 2/5. So 1, 2, 3, 4 2/5 is about right there. Wow, look how close I got to that just by freehanding.
So proud of you.
I am. All right, and then the domain's pretty easy to figure out. The domain just says, hey, we're going to go from negative infinity to negative 5 and from negative 5 to infinity. Okay, this is all what yesterday's was. Yes? Seem good?
Yep.
May I move on?
Yeah.
Whoa. What happened? You fall asleep?
No. No, I didn't fall asleep. Ow. Where am I,
man? Quit bullying people, guys. It's not fun. If you're gonna bully somebody, bully me.
Nah, bullying.
Did you give him a hornet?
Don't give him a hornet.
I didn't put a staple there. Not a jerk. No, he's really
Just have to get it on the forehead.
All right, we ready to move on?
I fall asleep now.
Well, I hear thumping and I hear the door slamming and you're like, oh, I thought you'd fallen asleep. I'm like, dude. All right.
You're closing your eyes a little bit.
So,
I'll wake you up.
now we're going to start dealing with when we have a rational function. I'm not adding or subtracting. The whole thing's going to be a fraction. So, when we look at this, we are indeed still going to get the hyperbolas. We are. What are you doing?
I'm scared I'm going to get hit. Is he
He got
laughing
stuck
up?
in his hoodie.
I want to get face shotted.
You just did it to him.
If you did it to him, man up and take it back.
I didn't like that.
Oh, it was funny when you're,
Yeah.
you get a little.
Ow.
So we can't vote for like
Here.
Oh, good stuff.
It's not your class.
Good stuff.
Makes sense.
All right, now I can teach again.
Gross.
All right, so when we look at this function, vertical asymptote is still related to that. Okay? Vertical asymptote is still related to that. So it allows me to say that x is equal to positive 2 for your vertical asymptote. But if you have your degree on top and your degree on bottom equal, they're both 1 here.
I don't think I'm serious. Just spread the word.
We ready?
Oh, so is it like a fraction?
It will be. So, cupcake and sunshine back there, just out of control. All right, what is the exponent on the top where I have the red box? Is it to the 0, or is it to the first, or is it to the 10th?
1.
First. What's the exponent on the bottom?
1.
Also 1. So would you agree with me that the exponent on top and the exponent on bottom are the same?
Yes.
Yes. So in order to get because they're both to the first power, right? So what they do for you here for my horizontal asymptote, it's going to be y equals this number over the number here. So 2 over 1, so that's just 2. Okay? That's a little different than what we had worked on yesterday when we had a number outside. So you have to look to see if your degree on top and degree on bottom, if they're equal, it's the lead coefficient over the lead coefficient as your horizontal asymptote. So this talks about where does our vertical asymptote take place. This one, the vertical asymptote, it was just that it set in the denominator equal to 0. Okay? And then with the horizontal asymptote, it's the lead coefficient over the lead coefficient as long as the highest exponent on top and the highest exponent on bottom are equal. So let's see if we can generate this. That's just more to read. All right. So vertical asymptote. I'm going to take this, set it equal to 0. So x is equal to positive 2. So I have a vertical asymptote at 2. Good so far? Of course, it goes all the way up. This one, my horizontal asymptote, my degree on top is 2, or 1. My degree on bottom, my lead coefficient's 1. So my horizontal is going to be y equals 1/2. Good enough? My graph is still going to look something like this. So because the line had shifted up because of my horizontal asymptote, it is going to have a root. Because it shifted to the right, setting the denominator equal to 0, it will have where it crosses the x-axis. So let's find the roots. So I'm going to plug 0 in for my y value and solve it. Multiply it over there, so I wind up with this, plus 1. So x equals -1. So -1 is my root. Good enough? My y-intercept, I'm going to plug 0 in for my x value. So I plug 0 in for the x. Looks like 0 over that, so it's just going to give me -1/4. So 0, -1/4, like right there. Domain, we're going to look at the red asymptote, so I'm going to go from -infinity to 2, 2 to infinity, less than u. And then now we're going to incorporate the range. Does the graph go continuous up and down?
Yeah.
Or is there an asymptote in place? It's an asymptote. What color is the asymptote? Blue. So my range is going to go from -infinity up to 1/2, and from 1/2 to infinity. And I guess if you wanted to plug in extra points, you're like, hey, what is -2, -1, 0, 1, 2, 3, 4? If you want to plug those in and do some magical points, you can. There's no reason to. Does that make sense so far? May I move on?
So at 1/2 it would be 0 then? That's why it doesn't work?
1/2 would be undefined.
Oh, okay.
If I plug 1/2 in, my denominator becomes 0. That's what I want. All right. So let's walk through it. Vertical asymptote. It's where the denominator is 0. So where's the denominator 0? 4. By this happening, it tells us it's going to cross the y-axis guaranteed. Okay? We don't know if it's going to cross the x-axis because we don't know if we have a horizontal asymptote yet, but it looks like we do because those are both for the first. That's a 2 over 1, so I get y equals 2. So now we will definitely have roots. Nothing real too squirrely, so it's going to look like this and like this. Let's see how close my graphs were. So if I want roots, I'm going to plug 0 in for y. And so I get 2x plus 3 over x minus 4. Multiply both sides by x minus 4, it goes away. So I get 0 equals 2x plus 3. Subtract 3. And then x equals -3 over 2. So -1 and 1/2. So negative. Why didn't anyone stop me on this? Goofed up my asymptote. Sorry. No, I was right. I was right. 4, positive 4. My root is negative. Wait, did I do my math right? 3. So my picture is going to be off a little bit, so I have to readjust it. So my negative 1.5, comma 0. So I guess this one actually looks like this. So I had to adjust it a little bit. I might have to adjust it again to find where it crosses the y-axis. To find where it crosses the y-axis, I'm plugging 0 in for my x's. So I'm going to get negative 3/4. So 0, negative 3/4. So this purple line is off a little bit. Of course, when I just freehand it in, it's going to goop up. And then my domain, take a look at my vertical asymptote, my green line. So negative infinity to 4, 4 to infinity. My range, I have a horizontal asymptote, so it goes from negative infinity up to, what was that line, 2? And from 2 to infinity. And again, if you want to have fun times, plug in some values.
Why is there a spike on the flag?
Dude, I don't know.
Speed.
It's decoration.
Yeah, bro.
Am I done? I got this one. Oh, cool. Last one. Man, I'm getting done early. I feel like I'm forgetting stuff. Okay, talk me through it. What's 4? Yeah, so x equals 4 is vertical asymptote. Is everyone okay with that?
Yeah. And then it's 1.
Horizontal asymptote, it's what?
1/1. So it's
Nope. What's my highest exponent here?
Oh.
That's a 1, so it's out of order. So what is it now?
It's 2.
Close?
-2.
Negative 2.
-2.
Is that all right? Does everyone see that? So they wrote it out of order. You got to be cautious on these sometimes. Sorry about that. It's like what math teachers enjoy. Oh, look, I confused my kids. It's like, man, you suck as a teacher. Okay. I think this one might be a little goofy, so it might be better for us to figure out the roots. I think my thought process, and maybe we'll just do this in yellow. I think it's going to look like this. I think. But why would I say that? What's negative that sticks out?
-2.
The -2 on the top. But I don't want to put that for sure. I just want to kind of keep that in mind. Just think maybe we'll have that. Okay, so let's figure out some roots. We will indeed have some roots because it is shifted around. So if I want to find my roots, I'm going to plug 0 in for y. So it becomes 1 minus 2x equals 0. So negative 2x equals negative 1. So x equals half. So x equals half is like here. So yes, indeed, it's going to show that. Let's find our, what's that? Because basically all you're doing, this becomes 0, right? And then you solve it. 1 minus 2x equals 0. Subtract 1, so you get negative 1 equals negative 2x. Divide by negative 2. So it's positive half.
So that's how you get 2 roots? You just solve them as different?
Yeah, there's just one root that's going to take place. And then the y-intercept, I'm going to plug 0 in for x. So those become 0, so I get 1 over negative 4. Is that right? If I plug 0 in here and here, that becomes 0, that becomes 0, so I get 1 over negative 4. So negative 1/4. Like here. So yes, indeed. Our graph, like I had said, is going to do this, and this one kind of mirrors over like that. Domain. Negative infinity to 4. 4 to infinity. My range, negative infinity to the red, so negative 2. Negative 2 to infinity. And then again, some additional points, fun times. Plug them in and have fun with it and be like, wow, look at these cool fractions I'm getting. Mr. Sturp, do you know when you plug 3 in, you get 4/16? Great. So that's why I'm kind of jumping over that. So you do have kind of 2 points that you're able to find pretty easily as long as your asymptotes shift. But then after that, you're just kind of just gauging it.
So why wouldn't you do 0 equals x minus 4 as well? Yeah, another.
0 what?
You know, on the bottom. Why do you only do it on the top?
So what I'm doing, or you're talking about to get this?
No, to get the root, why do you only do it on the top one?
Because I plug 0 in for y, and I get this. Okay, I'm going to take that, multiply it times 0. So I multiply both sides by x minus 4, x minus 4. That just becomes 0, so then it's just this. And then you have to solve it.
Okay.
So it goes away. That's why it works. All right, so that was G, right? Dude, look at all these graphs we have.
Is this whole unit in graphs?
Yeah, for the most part. All right. You guys want evens or odds? You get to select.
Even.
Evens? All right, we're in.
Because we're cool like that.
So 11G, evens. Realize there happens to be a front and a back and a front and a back. So you have front, back, front, back. Not Facebook, Facebook. Sound good? So, hey friends, I just need to pull something up that I gotta look at my calendar. So I'm pulling my phone out because, you know, no one ever has phones out during class. So, the end of this week is the 19th, right? Then next week we have 22nd. Is Monday. Oh my gosh.
You're like 4.
I mean, like, dude.
Yeah, we're so close.
Yeah. Oh, Sunday, May 12th. Important date. Mother's Day. Saturday, May 11th. Piano recital. Okay, my daughter's playing. My friends, we are coming down quickly. We are coming down quickly to the end of the semester. And I have noticed that I'm starting to get some parents that are emailing like they're in a panic, like I had no idea my child was doing so poorly. And it's like, well, I'm sorry.
My mom knows I'm doing bad.
Well, but some people owe me stuff. Some people, you know, are doing, you know, have bad grades. Wait, no, this is an Algebra 1, so. Between my 2 Algebra 1 classes, I have 40% Fs.
Ow.
They don't do anything.
I'll
They
shoot a
do
line.
nothing. I'll get tests turned in with their name on it. I don't understand any of this.
Well,
40% F.
Are you going to drop a test grade at the end of the semester?
I will drop one for everybody else except for you. I'm holding you 100%
You actually
accountable.
got one.
No. Yeah, you have to have completed each and every one for me to drop one.
You still have room in your business calc class?
For you, yes.
Okay. Yes. Because I don't want to take college trade.
Oh yeah, that's a tough class. I have no idea.
Isn't college algebra really
Sounds
easy?
tough.
What are you teaching next year?
What am I teaching?
Business Calc.
I got business calc.
Second period, second semester.
Drew boy's already in there. He already lined up.
I might gotta get a little
Oh,
transfer.
damn,
man.
I can't take that.
What in person?
Why not?
Dude, what in person?
That's ceramics.
I don't know. What are the best 3 off periods?
I don't
Class 7.